Hello, this video is all about filling loops, how to install them, where to install them. Has your filling loop started leaking and you need to replace it? For instance, why is this valve bigger than this valve? Why have they got arrows on the side of them? Is that important? Why has this got a screw on the front of it? Is it important if you put this valve on central heating or this valve on the central heating side? It is really important. And why is a filling loop even like this? You even got a cap wobbling around. I mean, what's that all about? Well, I'm going to explain all that to you in this video. Kicking off with the first question, which is, what is a filling loop even for? Now, I bet you were going to say it's to top up your boiler. Well, yes, it does top up your boiler and your central heating system, but that is not its primary purpose. It doesn't have all this malarkey on it just to fill up your boiler. It has a primary purpose. Otherwise, it would just be a straight bit of pipe with a couple of valves on it, or even maybe one valve. And of course, the answer to that question is really important and will give you a better understanding of what you're doing with your filling loop. Now, whilst you're just mulling over that question, I want to let you know that I've had a look over the internet to see what other people are saying about filling loops. And I haven't managed to find one single video where anyone mentions exactly what a filling loop is for, what its primary purpose is. So I want to say that I am the first person on the internet to explain to you exactly what a filling loop is for and how it should be used. During the video, I mentioned other help videos which are made, like how to use compression fittings, and I'll leave all those linked in the description below. And of course, in the description below, you'll also find lots of other really helpful videos on how to help you with essential heating, like how to change a leaking radiator valve without even draining the system down. If you want to add some smart controls to your system, how to go about doing that. Like I said, you'll find all those linked in the description below, along with lots of other helpful videos. So do check those out. And finally, at the end of the video, I'll show you a filling loop that doesn't comply to building regulations, a couple of things you should watch out for, and a really useful tip. So do try and stick around for that. Right, now let's get on with the video and explain to you exactly what a filling loop is for, how to install it, and how you should use it. So what is the primary purpose of a filling loop? Its primary purpose is a safety device. It is to protect you and your family from your central heating water because you don't want to be drinking central heating water with chemicals in it. And that is its primary purpose. The second is to fill up your boiler. But the main thing, it's got all this malarkey on it to protect you from your central heating water. Now, you might be thinking, is it even possible to drink your central heating water? Well, in the first clip, I'm going to show you a property where the double check valve has failed and central heating water is going where it shouldn't be going. Right, let's take a look at this filling loop, see exactly what is on it and where these components should be fitted. So this smaller valve, the shorter valve, this is an isolation valve. So if I just unscrew it from the filling loop and I open it up, you can see it's just a straight hole. You can see straight through it. Okay, so this valve here should be fitted on the central heating side, not the cold water side, on the central heating side. So that's where this valve here should go. And the arrow on it, because you see there's an arrow just there, the arrow should be pointing away from the central heating circuit. So it should be pointing towards the filling loop. That is where it should be going, and I'll explain why in the video. Now let's take a quick look at the filling loop where it joins onto the isolation valve. Down inside here, you'll see there's an O-ring. Difficult to see, but sometimes they can dry up and start leaking. So if your filling loop is leaking, all you need to do is replace that O-ring inside there. If you can't do that, you could just buy a new filling loop and just replace the piece of tube, and it should screw straight onto your valve. Okay, so the idea of this is so you can screw it on with your fingers. That is designed purposely so you can screw it on with your fingers, and you don't need to do this really tight. You can even leave it slightly loose because the O-ring inside is what's doing all the sealing. Let's take a look at the other end. Now this is the longer valve. Now this should be fitted on the cold water main side. So where the cold water pipe is, this is where this valve should be fitted. Now this valve is longer like this because inside the valve there is a double check valve. Now that's a building regulation. It has to have a double check valve. What is a double check valve? It's a valve which is inside here so the water will pass through it one way and it can't go back again. So the water comes in, it goes through the first valve, can't go back again, goes through the second valve, can't go back again, and then there's a isolation valve also. So you have 3 points of protection on this valve here, and this valve, like I said, should be on the cold water side. More importantly, central heating water cannot flow back through the check valves. And the arrow which is on this valve should be pointing away from the cold water side. If you get it wrong, no water's going to come out because water can't go through those double check valves the wrong way. Now, regularly when you get a filling loop, they're actually put together incorrectly. So this one here, this is literally just out of the bag, and this double check valve is the wrong way round. So this shouldn't be this end, okay? It should be the other way around. This should be unscrewed with the arrow pointing towards the filling loop. Okay, so that's the easiest thing to remember. Both arrows should be pointing towards the filling loop. And now water will be able to flow through here and top up your boiler. And if I open this valve up and we have a look through it, you can just about see those double check valves down inside there. There's one at that end, and we look at the other end, there's another check valve in there as well. So water can only flow through them in one direction. Now this filling loop here also came with a cap, and I'll explain a little bit later on exactly what the caps are for and how you should go about using them. Now this valve down here, this filling loop, this didn't come with any caps at all. And the design of the filling loop, this valve here, the double check valve, is slightly different, but it doesn't really matter. If it's a filling loop that's the regulations, it's going to have a double check valve and the isolation valves as well at each end. And when you're buying a filling loop, I always use or recommend to get one with handles on at each end. Don't get one which got a handle one end and then a screw thread on the other end. That's just really awkward and difficult to use. You're not going to have that screwdriver. And I regularly see these valves here being left open, and I show you that in the video. This screw here is not an isolation valve. It's for something else completely different. Now, if your central heating system is a little older, you may well find that the double check valve is on the central heating side. Now, about 30 years ago, that was a recommendation, I believe, but now definitely the regulation is to fit the double check valve on the cold water side for obvious reasons, which I'm going to show you in the very first clip. So I thought it was easy to explain the next part just on a whiteboard. Now, this is a traditional system. I was using this drawing to explain how to fit a hive system with Zo valves. But with a filling loop, it doesn't matter whether you've got a combination boiler or a traditional system. We need to put the filling loop somewhere. And it doesn't matter where you put it in the house as long as you know where it is and you can get to it easily. And you'll also need a pressure gauge so you know exactly how much pressure you're putting into your boiler or system. And also where you come to make these connections, obviously we have the mains water here. So we put our double check valve and isolation valve on this side. Now I've drawn the two check valves first and then the isolation valve. Most likely they're going to be the other way round. So the service valve first and then the two check valves. And then on the other side, where we've got just the isolation valve, it doesn't matter whether you connect it onto the flow side of your central heating or the return side of the central heating, because the pressure is going to equal over, it doesn't make any difference. But years ago, they used to say put it on the return side. So I'm just going to demonstrate that by joining the cold water to the flow side of the central heating system, red being the flow, green being the return. Right, so that's our filling loop all installed now. We've got the double check valve on the mains water side and the isolation valve on the central heating side. Now, how does this thing we're talking about where we start accidentally drinking our water? Well, what can happen is obviously now when we top up our system, the system pressure is going to be between 1 and 1.5 bar. Okay, and then we've got pressure here. We've got positive pressure. Let's put a plus there. Now on the other side, we've got our mains water. And our mains water might be similar, it might be 1.5. Up and down the country, pressures are higher and lower, and then you might have it up to maybe 3 bar. But what happens when you want to do some maintenance, okay? And you turn the water off, so now your water's turned off, and now you start working on some taps, and now you've got 0 pressure on this side. Now you have more pressure on your central heating side. So there's a possibility, because this has more pressure in it, that water can come out of your central heating system and force its way back through and into our drinking water. Okay, because here's our tap. We've got a tap right here coming off, which we're going to be drinking out of. And there's our water coming out. So that is why it's important that we have all these safety devices in place. So the first safety device is the isolation valve here. So that's going to stop the central heating water from coming out and going down here. Then the second safety device is a second isolation valve. And then if the water managed to get past there, we then got a double check valve and then another check valve. Hopefully that's going to then stop the water from going back into our drinking water and then drinking our water. The other really important part about a filling loop, which no one does or hears about, is this flexible tube here. It's made deliberately so you can easily disconnect it, so that you can disconnect the tube like that. So you just undo it And now there's no chance whatsoever that any central heating water is going to come out of here and into our drinking water because it's disconnected. And that is the thing which most people do not know. So when you finish topping up your boiler, you should remove this tube. Okay, so it's no longer there. And then you put your caps on to isolate your two valves. And I'm going to show you that in the video exactly how you would go about doing that. So here's a really great example of why putting the double check valve on the central heating side is a really bad idea. Now here's an old Turbomax boiler, and you can see the pressure there was at 1.8 bar. And down here you can see there's the filling loop. Now this is an older style filling loop. Here we have the double check valve, and you can see that there is no isolation valve on this double check valve. And also it's on the 22mm return pipework. And at the other end of the filling loop, we've got a T-style isolation valve. So this is the mains cold water pipe feeding the boiler. Now I know that this double check valve has become faulty, and I'll show you why in just a second. Now, if I unscrew the filling loop from the isolation valve, you can see some water coming out already. So let's keep on unscrewing it and I'll show you what happens. And there you go, central heating water is coming out of the filling loop. And right now, look what color that water is a dirty brown color. And if this isolation valve isn't closed properly, or maybe it lets water go past, that dirty central heating water is going to go straight into your drinking water. And look how fast the water's coming out. It's really coming out quickly. It's so much so that it's a struggle for me to screw it back on to the isolation valve. Now, like I said, if this valve becomes faulty or it's not quite closed properly, then that dirty central heating water can be going into your drinking water. Also, if you find the pressure increasing in your boiler or system, it may well be because the isolation valve on the mains water isn't closing properly. So mains water is continuously seeping past and topping up your boiler and system, which also you do not want happening, because that can lead to other problems, like overpressurizing your system, where then the pressure relief valve will open up, dumping that excess pressure, which then means more water will be added, so you get a continuous cycle of fresh water being added to the central heating system, which is incredibly bad. That leads to corrosion, causing black magnetite, which is going to block up everything in your system and eventually kill the boiler. You can see now that I've nearly got half a bowl of brownish coloured water, and the pressure on the boiler is slowly dropping away. So potentially all that central heating water could have gone into the drinking water. So obviously I'm going to change this faulty filling loop for a new one. So now I've dropped the pressure on the system, so I removed the faulty check valve. Now let's take a look at why this check valve has failed, and why putting the double check valve on the central heating side is a bad idea. So we're now looking down into the check valve, and you can see lots of brown rusty bits of magnetite. Over time, little bits of magnetite have got onto the check valve seatings and gradually jammed them in the open position, making the check valve completely pointless. And here's what the check valve should look like. Lovely and clean. And if we look inside this bit of pipework, you can see I can pull out bits of magnetite, which are just sat there, potentially blocking it up even more. Now I've finished replacing the filling loop, and take a look in this box at the little bits of magnetite I've pulled out. If you've not seen this before, this is basically rust which can build up in your system, and it floats around and it gets stuck in all the working parts of your system. Adding inhibitor into your central heating system can help prevent this magnetite from building up. And of course, if you want to know about how to go about adding inhibitor into your central heating system, then check out the video I've left linked above now. And of course, if you haven't got a magnetic filter, adding a magnetic filter to your central heating system is a really good idea. You can see here again all the magnetite that's been collected on this filter. And of course, I made a video on how to install the MagnaClean Professional onto your central heating system. Now, if we take a look at how I've installed this filling loop, You can see that the check valve is on the mains water side and the isolation valve is on the central heating side. So hopefully none of that dirty magnetite can get into that check valve and stop it from working. Now all that's left to do is to top the system back up again to around about 1 to 1.5 bar. Now I'm going to show you how to replace and install a new filling loop on your system, because once again this filling loop is faulty. Now exactly the same as the last filling loop, we've got a double check valve here and we've got an isolation valve here. Here's the mains cold water pipe coming into the boiler, and you can see there that the isolation valve is connected onto that bit of pipework. Rather than a handle, there's a screw slot, so you use a screwdriver to open and close the valve. And you can see the filling loop comes round straight onto the central heating flow pipework. And we can see the pipe comes round and into the isolation valve for the boiler just there. Now here's the double check valve and there's no isolation valve. The connection onto the pipework is a much better design because magnetite isn't going to fall down into the pipework. It's got to go up into it, which is not so likely to happen. Now to operate this filling loop, you use a flathead screwdriver like this. We just place it in the slot, turn it a quarter of a turn, and that will open up the filling loop. And once you've finished topping up your pressure, you must make sure that you fully close the valve. So the slot goes across the valve. In that position, the valve is closed, but it's very easy to leave it on a very slight angle. So the valve is very slightly open, and then you'll continuously top up your boiler. Just one drip a day over a week will increase the pressure in your boiler. So do make sure that the screw slot is exactly 90 degrees to the pipework. And in general, I don't recommend or use this style of filling loop, although they are cheaper to buy. Now once again, this double check valve has failed. You can see when I unscrew the filling loop, remove it, you can see that water continuously keeps dripping out of the pipe. So here's my new filling loop. Now this filling loop has a handle on the isolation valve and also on the double check valve, making it safer and easier to use. Here's the double check valve, and on the other end we've got a straight hole through on the isolation valve. So I'm now going to replace the filling loop. I've turned the mains water off. As you can see, the tap is open now and no water's coming out. Now I can come to this isolation valve and remove it. I use 2 spanners, one to hold the valve and one to turn the nut on the pipework. I can then loosen off the nut and remove the isolation valve. Now I've got quite a bit of water coming out there, so I'm going to put the valve back on again and just do a quick swap over, so I'm not draining the rest of the house of water. Now, like I said in the introduction, I'm going to now put the double check valve on the mains water pipe going into the boiler. When I fit the valve, I've got to make sure that I get the valve the correct way round. So there's an arrow on the valve pointing in the direction of the flow. Now I'm going to use some joining compound as I do on all my compression fittings. So I smear a small amount of joining compound all around the seating of the valve. And now that's ready to be fitted. On this occasion, I feel there's no need to replace the olive and the nut. They're both in perfectly good condition, so I can fit the check valve straight onto the original nut and olive. And despite what you might read or people say, there's no need to replace an olive every time. But of course, that does depend on the condition of the olive and nut. If you do want to replace the olive and the nut, then I've made a video 5 ways to remove an olive. And of course, if you want to know more information about how to put compression fittings together, I've made a video how to use compression fittings, showing exactly how to use compression fittings and all the different ways of sealing them so you won't get any leaks. Now I can use my adjustable spanners and tighten up the nut onto the double check valve, keeping the check valve straight and level and making sure that the handle is easy to see and use. And there we go, that's the double check valve now installed. I can now attach the filling loop to the double check valve. If we take a look at the isolation valve, we can also see there is an arrow on it pointing in the direction of the flow. Now in this situation, we're trying to stop the pressure from coming out of the central heating system. So that is the direction of flow. So it will be pointing towards the flexible filling loop. Now if we take a look inside the valve to see why that is the case, you can see at this end, there's just a hole in the brass fitting. And at the other end, we can see there is a retaining clip holding the ball valve in position. So we want the pressure on this side, pushing the ball valve onto the seating. If we fit the valve the wrong way round, then pressure will be pushing against that retaining clip, and the ball valve could be pushed off its seating, causing it to leak. So that's why it's important to make sure that you fit these isolation valves in the correct direction of flow. The next step is to drain all the pressure out of the central heating system. And we're going to do that by using the drain valve on the bottom of the boiler here. These drain valves are really easy to use on the bottom of the Valiant boilers. If you don't have a drain valve on your boiler that's easy to get to, then of course I've made a couple of videos on how to go about draining your system. So do check those out on ways to drain your system down or just drop the pressure like we are here. So I just push a rubber hose onto the drain off point. I then use a small adjustable spanner to open up the valve. And there we go, it's just opened up. Now I'm going to open it a little further and drain all the pressure out of the central heating system. And there you can see all that pressure coming out of the tube, going into my bowl. And now I've got to wait for the pressure to drop right down to 0 on the pressure gauge. Whilst the pressure's dropping down, I can make up the isolation valve ready to fit onto the pipework. This little pot contains multi-purpose jet lube joining compound. Just before I show you how a filling loop should be used, let me quickly introduce myself. My name's Mark Ballard and I've been a gas registered engineer for over 30 years. The aim of my channel is to help you with your gas boilers and your central heating. If you find this video at all useful, then please give me a little bit of feedback by clicking on the old thumbs up and subscribe. That will help others to find the video and of course share it with anyone else who may be interested. If you visit my website, I've categorized all my videos on products and parts that I recommend so you can easily find what you're looking for. And if you fancy getting yourself a DIY t-shirt or maybe a mug, then check out the shop below. And I'd like to say a really big thank you to everybody who's bought me a cup of coffee and left me a donation in my Toolbox fund. It's really appreciated and it does really help me to make more videos which will hopefully help you. Now here's my isolation valve all made up. See that joining compound all around the seating of the valve. Now it's just a case of removing the old double check valve and installing that isolation valve. But first of all, I'm going to close the drain valve on the bottom of the boiler here. That will help prevent more water from draining out of the system. And there we go, nip that up and remove the tube. Now this is a good point. Look at how clean this central heating water is. It's virtually crystal clear. That means the system is in good condition. Once again, I'll use 2 adjustable spanners to loosen off the nut. Then I can remove that old double check valve. Now to stop more water coming out of the central heating system and possibly getting air into it, I'm just going to do a quick swap over. So I'll close the valve, take the double check valve off and pop on the isolation valve. Now I've hardly lost any water out of the central heating system and no air has gone into it, which could possibly give me airlocks. Now with this isolation valve, I need to open it up so I can grip the valve with my adjustable spanners. See, I kind of hold it on an angle there. Now I can use my other adjustable spanner to tighten up the nut. And there we go, we just nip that up. Now you don't have to do compression fitting nuts really crazy tight. You just got to nip them up and then go maybe a quarter of a turn more. And that's it. You don't have to go crazy and make that olive scream. You just got to nip it up so it's nice and tight. Make sure that the valve is straight so it all looks nice and neat. And there we go. That's that done. Close the valve. And now I can attach the other end of the filling loop. Now notice here how the filling loop tube has got a nut on it which you can do up with your fingers. You don't even have to do this one up tight. You just got to do it up till it stops and that's it. And there we go. That's the new filling loop all installed and ready to use. Let's have a quick look inside that old check valve. Now you can see there's bits of rust and dirt and stuff trapped down in there. And of course, that's what made this double check valve start leaking. Now I'm going to show you the way filling loops should be used. And I would say probably around about 99% of homeowners do not know this. So first of all, I'm going to open up my cold water inlet valve. You heard a bit of water flow into the tube. And then I go to the isolation valve on the central heating and open up the valve. As I do so, I'll hear some water going into the system. Now I'm going to keep an eye on the pressure gauge or the pressure reading which is on the boiler. And I'm looking to top the pressure up between 1 and 1.5 bar. And there we go, 1.5 bar. So I'm now going to close both the valves. Close the isolation valve. And then close the cold water inlet valve. Make sure both handles go across the pipework. When the handle is across, the valve is closed. When the handle is in line, the valve is open. Now the next thing you should do is now remove the filling loop tube. Now this is the part which no one does and no one knows about, because the idea being is that once the tube is removed, there's no chance at all that any central heating water can backflow into your drinking water. You can then undo the filling loop at the other end and stow the filling loop somewhere near your boiler, because of course you don't want to lose it. And that's why the filling loop has those easy to turn handles so you can easily remove the tube. Some filling loops are supplied with a cap, and the idea there is you then screw the cap onto the valve so that if you accidentally turn the valve on, just give it a knock, you're not going to get water pouring out, damaging your house. And there you go, I can now open up the valve and no water comes out. Now this filling loop was only supplied with one cap, and I would recommend putting the cap onto the cold water inlet valve if you're going to remove your filling loop. The reason for that is if you accidentally turn the cold water valve on, water is just going to continuously keep coming out, basically flooding your house. But of course, if you accidentally knock your central heating valve on, you're going to get water coming out of there as well. Although once all the pressure has gone from the central heating system, no more water will come out of that valve. So the ideal solution is to have two caps and cap off the cold water inlet valve and the central heating isolation valve. Having said all that about removing the filling loop, 99% of the time, this is the way I see it. The filling loop attached and the two caps just dangling next to the valves. Now, if you leave your filling loop attached like this, the likelihood of water getting past the first isolation valve and then past the two check valves and then past the second isolation valve is fairly unlikely. But still, it's a possibility, and no one wants to be drinking their central heating water because that cold water drinking tap is right there. Now, hopefully you understand why filling loops are designed the way they are. And like I said in the intro, their first priority job is to protect you from your central heating water. And the second job is to fill up your boiler. So I hope that's all made sense to you. Now I'm going to tell you about a few things to watch out for and a really useful tip. Now I saw a video clip of someone saying you need to adjust this screw here, which is completely wrong. When you have a double check valve with an isolation valve on it like this, the only reason for this screw here is you could take it out and you could possibly poke something in to push the check valve open if the second check valve has become stuck. Now, another common thing with filling loops is sometimes when you open them up, the filling loop valve might start leaking, like this one here. You can see there is water running down and dripping off the bottom of the pipe. Or sometimes the flexible tube connection will start leaking. But it doesn't really matter as long as when you close the valves again, it stops leaking. Sometimes there can be quite a bit of water dripping. But like I said, if when you close the valves, it stops leaking, it's not normally a problem. But of course, the recommendation would be to replace the filling loop. Having said that, I've got several customers where when I top the boiler up, their filling loops leak. And they've been like that for many years. like this one here, and the homeowner knows all about it. Now here's a super handy tip for all you plumbers, heating engineers, and of course homeowners. If you haven't already realized it, having the isolation valve on this central heating side means it is super easy to drop the pressure on the system. Detach the filling loop from the double check valve, open up the isolation valve, and dump all the pressure in seconds. It's really obvious, but sometimes it's not as well. And there you go, you can see the pressure on this boiler is now down to 0. But on old systems where people have put the check valves on the central heating side, you can't do this. So I hope that's a useful tip. Now, if you're wondering what's going on with this boiler, the internal pressure sensor is reading there is pressure, but we can see on the pressure gauge that there is 0 pressure in the boiler. So this boiler has a faulty pressure sensor. And I have a video all about that. If you're replacing a filling loop or installing one, this is a bit of a bad design because any central heating water which comes down this return pipe, if the system's dirty, little bits of magnetite will fall down and will start blocking up that valve. Or when you top the system up, it's going to suddenly blow all the bits of dirt up into the boiler, which again is bad, and you don't want to be doing that. Now here's a demonstration of what a filling loop should not look like. So there's our central heating pipe, there's an isolation valve there, and then you've got another isolation valve at the other end. So there's no double check valves on this filling loop at all. And you can see it's just a push fit flexible tap connector that's been used to create a filling loop. Definitely contravenes the building regulations. And putting a filling loop in a really awkward place is never a good idea. And you can see on the cold water isolation valve, it's a screwdriver slot which I need to turn to open up the valve. I regularly find screwdriver slot valves in the open position, which is why I always recommend using handles. That leads me nicely onto this clip here. Here we have a pressurized central heating system. You can see the filling loop just there, and the cold water inlet valve with the handle on it is closed. But when we take a look at the isolation valve on the central heating, it's been left open. So central heating water will be pushing down this tube and pushing against those double check valves and isolation valve before it starts entering into the drinking water. So of course I've pointed out to this homeowner to make sure that he keeps this valve closed. Wherever you're fitting a filling loop, you'll also need a pressure gauge to make sure that you're not putting too much pressure into the central heating system. You can see down there, there's a pressure gauge which is fitted onto the pipework. But now you can buy filling loops with pressure gauges already on them. Now here's a couple of clips of filling loops which are on combination boilers. Now you can see here underneath this Baxi boiler, there's a filling loop. We've got 2 caps just dangling there, and we've got a double check valve and 2 isolation valves. And that little copper pipe there is the filling loop. And that pipe has probably never been removed ever since the boiler was fitted. Here's a Valiant EcoTech Plus. This is an older boiler, but the filling loops on the Valiant boilers are still the same today. So underneath the boiler there, we've got 2 handles. There's that water coming in, then it goes into the isolation valve, and then we've got a double check valve behind it. And right next to there, there's a little retaining clip just there. So you can unclip that and remove the filling loop. The filling loop comes around and joins onto the flow on the central heating with another isolation valve. Here's a Valiant EcoTech Pro. Now there's no built-in filling loop on this boiler. Instead, we have the external filling loop. And this is the loop that was leaking that I showed you earlier. Unfortunately, some built-in filling loops are a little bit rubbish on boilers. For instance, this glowworm here, this design is a bit of a nightmare. People have a real problem with it. And you can see one of the handles has just snapped off it. So this filling loop, not a great design. Now this is another filling loop which I don't like on a Worcester boiler. This filling loop I found once it was jammed and I had to take it apart to get it working. That is not what you want when you want to top up your boiler. So again, not a great design. Now I could keep showing you filling loops for ages, but different manufacturers use different filling loops. But anyway, I do hope this video has been helpful and it gives you a bit more knowledge on filling loops. Right, that's about it then. So if you want to know how to go about using those compression fittings, you can click on the video link just there. If you want to know how to replace a radiator valve that's leaking without draining the system, click on that link there. As usual, please give me some feedback with the old thumbs up, click on subscribe, share it with anyone else who may be interested, and of course a cup of coffee in my toolbox front is always really appreciated. Bye for now, and I hope to see you in the next video.